Welcome to a new test and teardown video. This time it's another DIY DC power supply. And this one is really old. But there's actually Model ELS 1012 written on it. We got a little bit of specification, maximum 0.7 amps. We also got, it's a power supply and the voltage range and stuff like that. It's quite heavy, and I don't know if the case is also completely homebrew. It looks a little bit like it was a case Ooh, we got loose parts in there. Yeah, so it is one of those cases you buy for constructions and stuff. Oh, look at the wire. It's really, really short. I got some 73. Yeah, I don't know exactly how old this is, but what I can see here is the front is made of acrylic and just a paper print. I mean, I've seen this kind of DIY front design before, and I really don't like it. I think you can make it look really nice and beautiful once it's really new. We better open and have a look. I don't know exactly what is the point with the double power outlets and a jack connector. So this is a 1/4-inch jack, known from audio and stuff like that. Yeah, I better open and have a look. I figured it's those two screws, right? So now I'm inside. It was a little bit funny, this really, really short wire. Of course I needed to do like that, and then pull the wire this way. And the two screws here in the back made it possible to pull back. The case is of course locked like that into the edges here and here and all that. I figured out this power supply is from 1975. I got a few leads on different things. For example, the date is stamped into the transformer. There is 75, and it's also written on the date code on that transistor right there. It's a mix of different transistors, some germanium, NPNs and PNPs. We got some Zener diodes, all sorts of funny modifications. I even see some handwriting right there. Maybe I can find some light at a nice angle and see if I can read what is written. So here's the output regulator, a 3055. Mains input is actually fused. It's not the safest. I don't know, if I pull this a little bit more, it's probably gonna fall apart. So mains goes to the transformer. This is the little neon bulb indicator. And obviously that switch. See, this one is a little bit interesting. I feel the 3 wires from the jack is a transformer tapping selector. Because you see, the white wire, the sensor tap here, there isn't any other. It has to be like that, right? So down there is the rectifier bridge. the white wire goes to the center, not the center. So you got 0, 30, or 37. So now comes the fun thing. The yellow wire goes to the other side of the AC input. So yellow wire must be either connected to red or blue, and then it should light up this power supply. It really, really looks like somebody had a lot of fun. But 1975, and what is going on with this one hanging here? Maybe it was some sort of an experiment, and then they just, okay, let's, what the hell, put it back and then put it on the, I don't know, storage, and now it's here. What is going on here? Let's see if I can get anything out of this. Got all sorts of funny wires just hanging all over the place. See, here's a little resistor. And there's another resistor hanging there. I feel this, this is probably maximum current, right? Those trimmers, I don't know what the... I measured the banana jacks here, and the two black ones, they're connected together, and the two red ones, they're connected together. So this is quite smart. You can put in a voltmeter, and then you have your user, or you can power two things at the same time. So I took out the circuit board to have a much better look on the back. And it turns out we got some information written here on the back. Elektronikskolen. Yeah, that's quite easy to understand, isn't it? So it's some sort of a school education facility. Regulated voltage supply. Or power supply, right? Got a little bit of information about where C1 and C2 and a little diode and stuff like that. So that's just how it is. I'm really sad about the circuit board is cracked a lot of places. Depending on the angle of the light and the camera, I can see tons of cracks all over the place. So it's probably gonna fall apart more or less when I poke around with it. But that is just how it is. This, I think it is really, really old. It's also a little bit funny to see here inside the bottom of the case. I find a cardboard isolation sheet with some marks. And that was, of course, in here. And we got all sorts of funny corrosion. Look at that. Oldie. But I think I'll just try and assemble it again and see if I can clean up some of the wire mess, and probably, I hope it works. So here is my next little move. I took out all the capacitors. They are really, really old and super gross. And look at that. 4 of these tiny little ones. They were supposed to be main charge capacitors. They're only 100 micro. I mean, of course, somebody figured out we want 2,200 in parallel to get this one working. The output capacitor, that is 1,000. And then the filtered drive voltage for the driver and output stage drive signal is decoupled by these two. So I changed all of them. That'll be the output. I also added some epoxy to the circuit board, especially on the back side. That's I changed them to 470 micro, and now I got 4 of these, and that will be the other 2 capacitors. I didn't change anything in the circuit yet, but I want to replace the wires here. They're of course stiff wires, and they're super annoying when you want to take out stuff. They always break and crack and creates all sorts of problems. Voltmeter is connected to the circuit board, not the output. That is one problem. If the wires to the meter goes directly down here, it's actually easier to pull out the circuit board. And also this is the reverse bias diode. You always have this in a power supply, and it points from minus to positive, and it's very, very important to have this in case you parallel or series power supplies. Yeah, you want this diode so you have control of that. And I figured out the two trimmers here. See, the black one is the center of our voltage set point. Yellow is one side, and then there's a red wire as well right there. So the two center side, or the two sides of the voltage set potentiometer here, they go to these two trimmers to set the minimum and the maximum. That is a little bit funny. Why is it done like that? And why is it placed where it's super annoying? I mean, you could probably put the trimmers somewhere up here where it's nice and easy. Of course, this is mains voltage, so this is the nasty side. So I'm not super happy about those trimmers and those wires. So I will have to fix this as well. I think this unit clearly needed a deep cleanup. It's so nasty everywhere. If I remove everything here, I can probably also clean this. I got a little idea about how I can fix this. We'll see if I'm lucky with that. It's a little bit fun with this. Yeah, let's see. Oh, look at that. I think this is probably paper, dissolved paper pieces, because if I look here at the back, it's probably some of the paper that's falling apart, but it's still good enough for I can do a scan and a reprint, and then I could maybe, what if I spray paint the paper with clear varnish? Maybe it will handle moisture a lot better, because you can see this is really nasty, and if I touch this, it turns into creepy dust. And look at that, needs some cleaning. Well done with all the filing here and the holes and all that filing and fixing. Oh, we have a little crack here. But as you can see, this is one of those days where it goes a little bit longer than normal. So we are outside because I've tried to clean the aluminium as much as I could. And it is a little bit corroded. But I will give it a thin layer of spray paint, and hopefully it will cure the aluminium a little bit. So here's a little trick. I use my good old scanner. Just scan this in 600 dpi, and a little bit of Photoshop and a little bit of fixie, and then print it out in exactly 600 dpi. And there you have it. It's exactly the same layout, same fonts, everything is the same. I added these crosses in the middle of all the holes so I can verify that everything matches the right sizes and everything like that. And if I put it exactly where I want, I think it's going to be just fine. I really don't want this hole anymore. That was the jack connector. It's not in. It's just not doing anything for me, to be honest. So that's why I removed that one. I need to figure out a way to block that hole. This is okay with the case. After a little bit of sanding, a thin layer of white spray paint. I think I covered up the corrosion. See, quite well and sealed it a little bit for the future. So now I will try and put in my paper print, and probably I think I should glue stick it to this front and then try and cut it and all that kind of stuff. Yeah, I think that's gonna be all right. Oh, one more thing. Look what I found. 173 TO 1155. Could that be a 1973? I think it is. This is the first team of 73. And TO is probably his initials or something like that. Or student number or something. That's just my idea. I also fixed the meter. Everything is made of transparent plastic. That's really, really a cool meter. But I don't know if you can remember earlier in the video, this aluminium holder here, it was corroded badly and looked real bad. So I kind of sanded all this corrosion away and gave it a thin, thin layer of paint. So I hope I'll still be able to reassemble everything here. The hole in the acrylic front here, well, I could of course just go and laser a new acrylic front, but I think it's a little bit against my restore thing instead of just replace things. So I want to try and see if I can remove this hole in the acrylic. How are we going to do that? The first thing that comes to my mind is a 3D design. I just made this super simple design. Let's 3D print this and see if it fits the hole. So after 3 minutes, we get this little part out of the machine. Now I think if we can just put it in the hole like that and just press a little bit, see? Oh, look at that. And it even fits the front like that. So it's flat at the right height. Oh, what kind of success is that? And since we have this white paper on the back, I don't think it's going to be super visual, but at least we don't have this ugly hole anymore, right? So look what is going on here. The circuit board is now cleaned up and epoxied, and I am going to add a little extra epoxy on the weakened and broken and cracked locations. So hopefully that's gonna make it a lot better. And also the case, I am now in the reassembly of the case after a little bit of fixing this and that. So here's my paper, print out and everything like that. So I also washed the banana plugs, cleaned the potentiometer. I didn't even change it. That's so funny. The knob itself, I'm not super happy about this one. See how nasty that is. This is about the nasty level of the entire unit. So of course we want a new one, and we're gonna add a little this one. I think this is gonna fit real good. And the meter is also nicely fixed. You can probably remember the nasty corrosion down there is also removed, and I gave it a thin layer of white paint to cover up the corrosion. You can see it's really nice and pretty, and that is the meter cover. Clickety click. So I think it's gonna look real pretty in a minute. There's a big difference, isn't there? So before assembly, I of course go and check the different parts. And the meter seems to be quite all right. So this is 10 volts. Let's try and give it 20. I mean, this is just within what you could expect. This shows a little bit too low. But what I can do is just remove, the wires and see, is it at correct 0? Yeah, it is okay. This is just the way it is. So now I'm done with all the wires. It's much easier to do all the wires before the circuit board comes in. So I have a plan for where all the wires they go out here to that side. And I think I can take my circuit board with everything here like that and just carefully put it in like that. It should fit the holes and all that stuff. More or less like that, right? And of course I found some real big plastic washers, and I think they will be okay because I got some broken parts of the circuit board's edges and stuff like that, but with real big washers I think it's gonna be alright. I got a lot of good news. Since I started playing around with this power supply, I took some pictures from the circuit board, the top and the bottom of the circuit board, and I posted in a local Facebook group with a lot of experts around. After a few days, this design was identified. And it's actually a little bit impressive because this circuit board here is a copy of a Josty-Kit design. It's called NT30. And if we look at the pictures we have found from the different Josty-Kit groups, we can see the board is very much the same when it comes to component placement and all that. And my PCB design is made like a recreation on top of the original one, and they even added all sorts of text and all that stuff of their own, and they didn't reuse the design idea that Josty-Kit always do with the big copper areas kept and big fat tracks and all that. Oh no, they made all the tracks really thin and slimmy. Anyway, the Josty-Kit design was released in 1967. Here is the catalog from 1967. And also in that catalog, we find this meter. It's called EW16. So everything here was from that kit, and even the transformer is also the same. So that's a little bit interesting. So they bought all the components, or at least the transformer and the meter, from that catalog, and then they copied the design for this this school, electronic school. Yeah, by the way, it's now it's completely done and ready to be tested and all that. I've of course been playing a little bit around with it. I've adjusted it for 12 volts, and it just keeps the perfect setting. I removed the two trimmers, as you can probably remember earlier in the video, and the original design had trimmers here, and they went in series with the voltmeter, potentiometer, and that's really a bad idea. It's not stable or anything like that. And it goes from about 8 to about 30 as stated on the front. I've of course played a little bit with fixed resistors to make this happen. And here's the funny thing. Let's put it for 12 again, just for good measures, right? Ooh. Like that, right? So let's put the voltmeter here in AC mode. Not a damn thing, right? So let's try something a little bit more interesting. Both of these outputs, they are of course perfectly parallel in this unit. So I've put my DC load on one of the outputs, and the other output I measure the output voltage, right? So let's give it 100 milliamps. 2, 3, 4, 5, 600 milliamps. And let's keep it at 600 and then turn the output off and on, off and on. So it's quite well regulated with just a few transistors. No op amps and no fancy smancy design here. No. Just a couple of transistors. And that is really, really amazing. This is so simple. I should probably show you the schematic once again, and you will just be amazed how simple this design is, and it is that well performing. So let's go back here. We are on at 600 milliamps. Let's try something funny and overload it a little bit. So this is 700, 800. It was supposed to deliver only 700. So this is a little bit extra, and I give it now. Oop, see, it turns off completely. And we can just go down again, and then it still works. So here's a half an amp. Fantastic. Yeah, so I'm actually quite happy the way this went. I don't know. I really would like to have a comment from you guys. Do you think I went a little bit over the top? Or was it exactly as you would have expected? I had a lot of fun. And it was, it was really possible to restore this into super good working condition. And it is really looking super duper good, both on the outside and on the inside, and all that. And now, yeah, we can put this back into its case. So thank you very much for watching. I hope you had a little bit of fun. Please tell all your friends, and please like and subscribe and all that things I always say. So bye bye.